Welcome, everybody. My name is Matt Simons. That's my name on the slide, bottom left. Woohoo! I am coming to you from the United States, and I work for a company called Workiva. So, the title of my talk, You Are the Captain Now, Becoming an Engineering Manager. If you missed the meme reference in the title, shame on you. I demand the immediate surrender of your nerd card. The door is over there. I need to start out by thanking the organizers for giving me the absolute best slot to speak in for the day. This is hastily scribbled in MS Paint, but if you look at sort of the audience distractions during the day, you start the day, you don't want the first slot, because the first slot, everyone's still kind of sleepy, the caffeine hasn't kicked in yet. And then before lunch, everyone's hungry. After lunch, everybody's tired, and then the whole afternoon is kind of a wash. So you are here, and this is the absolute best place to be. Welcome to the 3-act play. If you've seen any of my other talks, which you probably haven't, that's cool. I'm not that big a deal. This is sort of the structure. And the first act is all the same. The first act is always the why. Why are we talking about this? Why does this matter? Why are we here? So why are we talking about becoming an engineering manager? Specifically at a DevOps conference, which is kind of interesting, but really I guess the short answer is why not? This is as good a place as any, and we all need good managers, right? So this is for you if you want to become a manager, if you want to get better insight into what your manager does and why. If you work in software, you either have a manager or are a manager, so hopefully this is interesting to you. All right, the first section, beep boop, I am a bad robot. Let's talk about you for a moment. You are a robot. Not really, actually, you're a bad robot. We're gonna get into that. You're a robot. What do? You take in some input and you produce some output. So that makes you, in a sense, some kind of a robot, right? Or a computer, a machine. This is a fairly standard process that we participate in.
So you mean me as a developer as opposed to a manager, right?
Yes, as a developer. Thank you for clarifying. So I'm going to ask a question here. What are your scaling parameters? As an engineer, what do you scale with? Time? So experience? Yeah? What else? Tools? Yeah, as tools get better, then your output can increase.
I'd say coffee.
Coffee, caffeine. All right, yeah, some of those are captured in here. I put some basics. This isn't a complete list, but knowledge, experience, enthusiasm. Caffeine plays into the enthusiasm, definitely. And what are your scaling constraints? What are you constrained by?
My manager.
Your manager. Good call. All right, your manager. I think that plays into some of this too. Enthusiasm, bandwidth. So there's only one of you. Maybe this is better expressed as your base clock speed. You can only do so much work so quickly. And this kind of goes to a dark place, but mortality. Eventually you burn out. So as a worker node, you can vertically scale along these axes, right? And these are your constraints. But that's it. That's all you can do. At some point, you reach the limits of your vertical scaling. And at that point, what do we do in our industry? We seek to horizontally scale. So horizontal scaling is actually what we're talking about at an organizational level. And this is, if you're not familiar with it, again, kind of shame on you, but Conways Law, so that organizations which design systems, so build software, that's us, are constrained to produce designs which are copies of the communication structures of these organizations. So the assertion that I'm going to make here is that as we horizontally scale, we're just building organizations. These are companies, right? And what that makes us, if we are robots, is distributed computing platforms. An organization is just a distributed computing platform. It's a collection of bad robots. And why are we bad? We're bad because we don't necessarily always get the same results with the same inputs. You can give different developers, different people, the same input and get different outputs. We're kind of inconsistent. What's interesting about Conway's Law, though, is if we kind of look into it a little further and if we take it a step further, with which I think most people have and it's fairly safe to say you can, it's that we can look at our organizations and at our companies in sort of that same critical lens that we use to look at our software, our distributed software. So companies actually face distributed computing problems in the way that we communicate, in the way that we're organized. Now, there's a ton here. We'll kind of go through some. We have state management issues. So this gets into, well, let's talk about strong versus eventual consistency. So strong versus eventual consistency, when we're talking about distributed databases, distributed data platforms, is essentially a trade-off that we have to make between latency and accuracy. We have to decide, do we value the accuracy of the data across all nodes, the timeliness of that, over the kind of accuracy of response? Do we want our data to agree eventually or all right away? In our organizations, what does it look like? This looks like the way that we communicate ideas, the way that we communicate our state, how we are moving in the organization. How many of you think that you're in too many meetings? If you're in too many meetings, you favor eventual consistency. If you think that your organization doesn't communicate things fast enough, you probably favor strong consistency. These are the trade-offs. This is the problem that we try to solve. We have release pipeline issues. In fact, we often don't do enough testing prior to rolling out big changes to our organizations, and we don't usually have adequate rollback strategies. What happens if after we meld all these teams together and do this big change in the organization, it doesn't work and people are unhappy? What's our rollback strategy? We usually don't have one. We have a flail around and everyone's unhappy for a while and then roll forward strategy.
So even worse, you probably very often don't have an evaluation for a change, right?
I'd say that's pretty accurate. Yeah, oftentimes, and not always, but this is something that can happen, right? You've probably seen them in the organizations that you've worked for, where somebody makes a big change and it clearly wasn't properly tested or thought out ahead of time. We have split brain. We have leader election problems. The last talk actually brought up a slide that showed redundancy in different kind of industries, and there was a company, the global energy company, that had like 2,000 different accounting systems and 12 different initiatives to change them and consolidate them. That's indicative of split brain, right? Where we have a state issue, we have a leader election issue where people don't know what they're doing, right? The right hand doesn't know what the left hand is doing, and that means we have lots of parallel initiatives, people all trying to solve the same problem. We have availability problems. So we as people are not always available. We're not highly available. We're bad robots in that sense. We have to deal with injury, sickness, even death within our organizations. So we have nodes that fall out of the cluster, and we have to do replication. We have to spin up new nodes. We have to handle these problems as well. Those things can also identify single points of failure for us. Call it kind of your bus number is like the colloquial term that we use. If somebody gets hit by a bus, or how many people does it take to get hit by buses before we lose specialization in a certain area of our product or of our organization? And we have resource issues. So we have resource starvation. We're constantly in a state of resource starvation where we almost never have enough people to get done what we need to get done. And this one's kind of fun. Network links are unreliable. I have this theory that it's going to be the year 2085 and world hunger is solved and cancer is eliminated and we still can't figure out how to teleconference. So, as organizations, we face distributed computing problems. The thing is here, it's the same problems that we're solving now as engineers. If you're an engineer and you're solving distributed computing problems, these are the same problems. It's just a different API. Humans have a very different API. So what's our goal? Why are we doing this? Why do we do this? Why do we horizontally scale in companies? What's the goal here? The goal as managers is to be able to achieve consistent results on an inconsistent platform. So companies, people, a collection of bad robots, this distributed computing platform is an inconsistent platform, right? All the nodes can produce different results given the same set of inputs. So our goal as managers is to try and get consistent results on this inconsistent platform. So now I'm going to make an assertion. How do you do that? Well, your results are most consistent when the nodes are happy. When the nodes in the cluster are happy, generally speaking, you're probably going to have pretty consistent results. All right. We've talked about the why. Let's move on to more of the what and the how. This is titled Stupid Metaphors because, I don't know, it's kind of stupid and we're talking about metaphors. Who all has seen this before? It's a lot of hands. Okay, cool. This is bullshit. Pure, utter bullshit. Why? Well, because it's oversimplified. Now, it's useful. It is useful because it's simple, but it's too simple. And here's why. This draws the simple line that this top version is bad and the bottom is good. All right, cool. Now, before you get too angry at me, I'll say that this top version is still bad, and in fact, I'll go a step further and say that person is not a boss, they're just an asshole. But what I want to talk about is the bottom one. Is this good? Is this really what we want as leaders, as managers? All right. If your job looks like this, if your team's goal looks like this, and this slide didn't render super well, but there's a finish line over here, and if your team is right here pulling the business cart, right, and the finish line is directly ahead of you in a straight line, congratulations, this model works for you, right? But that's not what it looks like for us most of the time. Most of the time it looks more like this, where we're down here somewhere and we have to navigate a very complex route to get to the finish line, to get to success. And there's a lot of things that we need to do along the way. And our perspective is limited, very limited, right? We have this, when we're actually on the ground, our perspective is what's right near us. And that generally looks something like this. Tall trees, not very good visibility. We have multiple paths that converge or diverge ahead of us, and we don't necessarily know which one to choose. So from that perspective, how do you navigate the maze, right? There's a lot of problems that can hit you along the way. How do we know what path is best, right? We can have dangerous paths. There can be paths that we don't want to go down because the road is bad, or maybe it just takes a lot longer than others. We can have roadblocks. There can be obstructions along the way. There can be thieves or bears in the woods waiting to attack us as we go along our way. We can suffer injury and loss from people pulling the cart, right? Just doing their job. We can suffer injury and loss, and we have to be able to deal with that. The road can take us through foreign territory where we're not the sovereign owners and we are strangers. And sometimes one of the worst things that can happen is the goalposts can move. We can figure out as we get to the place that was supposed to be the end that it's not the end, and that in fact we need to backtrack quite a bit and go the other direction. So let's look at this now, kind of within this lens, and let's focus on this person pulling the cart. What is this person, if we were to describe them, All right, they're paid to pull. They're damn good at pulling. They usually enjoy pulling because they're damn good at it. They enjoy feeling valued. They enjoy being praised and rewarded. They enjoy success, seeing success, being a part of success, making success happen. And they enjoy feeling like part of the team. They generally dislike excess idle time, backtracking, others' opinions on how they should be pulling, and distractions while pulling. All right. So if we go back to all those obstacles, all those things that we just talked about, what does that mean? Well, it means that if we find ourselves at a place where the road is bad and we have to turn around and find a different road, we're backtracking. That's probably going to cause some idle time. That's going to make us unhappy. If we haven't cleared the road of obstacles, there's going to be some idle time. We're going to be unhappy. If we haven't checked for bandits in the woods or bears waiting to attack, there's going to be conflict. There's going to be potentially idle time. There might be backtracking. There's going to be problems. People are going to be unhappy. If we haven't negotiated the road ahead of time, paid the tariffs and taxes and fees to get through somebody else's territory, the cart stops and people are unhappy. All of those things that we just went through are essentially challenges along that path. These are distributed computing challenges that we have to deal with as managers. If the cart stops, people are unhappy. And not just your boss, not just upper management that want to see things done, but your developers are unhappy. Why? Because they like to pull and they're damn good at it. That's what they enjoy. We as developers want to be writing code. We want to be moving forward. It doesn't mean we want to be worked 60 hours, 80 hours a week. That's not cool, right? But it means, weirdly, we also don't want to be working 10 or 5. Or, the worst case, you show up to work and only have 5 or 10 hours of work during the week and sit there the rest of the time twiddling your thumbs. It's not cool. We're creative people. We want to be engaged. So I want to revisit this. We know that if this is you, your team will suffer. But I contest that if this is you, your team will suffer too, most of the time. There are times when you can be there, but you actually probably shouldn't be in front. See, the thing is, the problem that we make, the assumption that we make when we look at these two images is that they're the same person. They're both managing the team. In reality, most of the time, I think the manager is absent from that bottom frame. What's the manager doing? The manager is scouting the road. The manager is removing obstacles. The manager is clearing out bears, right? The manager is tending to the wounded and making sure that there's always enough people to pull the cart. These are the things that we as managers need to be doing. And we need to be training the leaders. There needs to be somebody in front of that cart. There needs to be somebody pulling and saying, let's go, guys. But that doesn't always need to be you. In fact, it probably shouldn't be. Part of what we should be doing as managers is cultivating leaders on our teams. So, this is what I believe. That sometimes it's appropriate for us to join in and pull, but probably not at the front. And most of the time, what we're probably going to be doing is clearing obstructions and making sure that above all else, that cart keeps moving, which we can't always do when we're pulling. All right, third section, house divided. I want to talk about sort of breaking this into its constituent parts a little more. We have 3 things that we do in business, or 3 ways we can kind of cut this pie. We have what we're doing, we have why we're doing it, and we have how it's getting done. As an engineer, you're told what to do. Hopefully, you're told why it's important. This is something a lot of people miss. And hopefully, you're not told how to do it. We call these people micromanagers. managers that come and tell us not only what our job is, but how we should be doing it. We don't like that. As a manager, you define what is important. You must communicate why it's important. And your opinions on how to do it probably suck. Because most of the time you're not pulling. You haven't done it for a while. Or you haven't really pitched in with the same gusto as your tech leads or other people that are really pushing the cart. So when you tell people how to do it, you're probably not right all the time. And it's best to try and get out of the way. So as we divide these up, this is your job now. The what and the why. People need to know what to do, and they need to know why to do it. When we combine these things, we call it vision. That people understand the vision, if they know where we're going and why we're going there. And it's important that people know why, because we can actually fill in gaps. It's not just the touchy-feely, right? Oh, I know why we're doing it. I'm bought in. Hurrah, let's go. That's cool. That's great. And that has a lot of value. But there's a functional requirement to understanding why. And that is when people understand why they're doing a project, they can fill in gaps. They can improvise. As we move forward in a project and we hit little obstacles, not big ones, but little ones, and we have to ask the question, how do I do this thing? We can go back to the why, and we can find something that aligns with that. If we don't know why we're doing a project, and we hit some sort of bump along the way, if I don't know why I'm doing it, my options are try to improvise anyways, probably screw up, risk losing a lot of work, needing to backtrack, and not enjoying my life. Or I need to go bug my boss, and I need to find out what's appropriate here. If we communicate why, we can generally get that improvisation without needing that constant back and forth, and without people feeling like they're risking the overall mission by improvising along the path. So this is our job now, the what and the why. What are we doing? Why are we doing it? This is what our engineers do. The how. We leave that up to them. They're creative people. This is what they love to do. I say they, we, us, you, right? This is why you're here. The problem is, this is what we love doing. This is why we got into the industry, right? We love the how. We love solving problems, technical problems, learning new frameworks and languages, and figuring out how to make things work. The how is baked into us. It's in our blood. It's not your job anymore. If you're the manager, it's not your job. It's one of the hardest things as we become new managers from being engineers is sort of divorcing ourselves from that, figuring out how to love our job, how to find satisfaction and fulfillment despite no longer being part of the how. But if you're going to do it right, you have to. Fairly early on, and I think this is a story that I think many managers, new managers, can relate to and can share. Excuse me. My team, like every team, had a task to do. And me, as a new manager, I stepped in, and this was an area that I was very familiar with, the specific product we were building. We were building a crisis response API, essentially a crisis response framework for our platform on Kubernetes. And I had built the previous crisis response framework for us on App Engine, where we hosted a lot of our code. So this was very familiar territory for me, and I had opinions on how to do it. Surprise, my opinions were actually not the best ones. And when you step in like that, it makes it very difficult for your team. It puts them in a very difficult position. You're the manager. They report to you. You have the ability to make their lives very difficult or very easy. You have control over a lot of their day-to-day. Conflict between you and them is not something they tend to encourage. So it makes it very difficult for them to then share that with you. You have to have a lot of trust. But my advice is just don't even put yourself in that position. It's okay to have opinions, and it's good sometimes to reality check, right? To sanity check, to get involved with the discussions, to stay on top of what the team is doing and provide little suggestions, questions, hints, things like that, right? What you don't want to do is come down and say, here's the project, here's what you're doing, here's why you're doing it, here's how you're going to do it. Stop after the second one. Let them figure out the how. Let them solve the problem. They love it too, right? Don't take their jobs from them. So, in summary, make your nodes happy. Your bad robots are ultimately what drive your company forward. They're pulling the cart. Make them happy and you'll find more consistency. We have success when people know what they should be doing, when they have clear direction, when they have clarity of purpose, they know why they're doing it, and when they're protected from all of those problems of distributed organizational computing. When we can clear the road for them, when we can choose the appropriate road, when we can help them find the way and get rid of all the obstructions and all the things that distract them from pulling, we can find success. So a happy team, we do this because a happy team has fewer team problems, and they're also more manageable. Inherently, problems are more manageable with the team when the team is happy. You have more capital to spend with the team, right? If somebody is unhappy, if the team is unhappy, if you're starting from that place and you have problems that arise, inherently those are going to be more critical. They're going to be more difficult to solve because people are already unhappy. So if you keep your team happy, it makes team management easier to begin with. And that consistent results will also make your boss happy. As a manager, your boss, and your boss's boss, and all the way up the chain, if you can provide consistent results, that makes them happy too. So this is your job. If you're a manager, if you're moving from an engineer to an engineering manager, this is now your job. And this is the job that you have. And it's not writing code anymore. I'm sorry. You can still do that sometimes where it's appropriate, where the path is short and straight and easy to see, you can jump in and help. But that thing that you started doing, that you love doing, you're going to find a new passion. It's the same problems, it's a different API. But ultimately, it's still the same thing you love. And that's what you have to do because you're the captain now. That's my talk. Thank you for attending.